Okay, now let's take up some interesting sums now. Let's see how we have it over here. We have, let's make this simple. This is, okay. So it's y is equal to x plus root x square plus m square raised to n. So as if this y is equal to this whole u raised to n. So we need to find dy by du first. Dy by du. Suppose it is, we are going to take dy by dx only. But suppose this was u raised to n is going to be nu raised to n minus 1. So nu, that is x plus root x square plus m square raised to n minus 1. We have done this. Into, we move inside this, we find the derivative of this. Derivative of x is 1 plus derivative of this alone is what? It is some variable raised to n. So it's going to, if you remember, 1 upon 2 root x square plus m square, because this is x square plus m square raised to half. So it's going to be half x square plus m square, half minus 1. That's not, now we have to go still inside. Derivative of x square plus m square is into 2x. So 2 gets cancelled. Now let's see what will this be. This will be n into x plus root x square plus m square raised to n minus 1. If you take the LCM, this is nothing but root x square plus m square plus x upon root x square plus m square. Now if you see, this term and this term are the same thing, so this will be actually n into x square plus root x square plus m square raised to n minus 1 plus this whole thing plus 1 upon root x square plus m square. Now n minus 1 plus 1 is nothing but x plus root m square. Now this alone is nothing but y, so it's eventually ny upon root x square plus m square. So you just see how when you take the LCM, the function itself repeats itself, and you add it up to this, you get n minus 1 plus 1. So it's x plus root x square plus m square raised to n, but this alone is y. So it's ny upon root. So we'll come across many cases while finding the derivative. One of the terms could be the function itself. You might get it, especially when you're dealing with powers which are in non-integral numbers. So you have ny upon root x square plus m square. Okay. Now here you have x cubed y square is equal to x minus y the whole raised to 5. Find dy by dx at 1, 2. So we need to find dy by dx. So it's going to be x cubed y square. So it's going to be x cubed into d by dx of y square plus y square into d by dx of x cubed is equal to d by dx of this, which will be 5 into x minus y raised to 4 into d by dx of x minus y. So we're using a composite function. It is a function, so you get 5x, then you find the derivative of this. This is nothing but x cubed into, again we are using chain rule. First we find the derivative as y raised to n, so ny raised to n minus 1, then derivative of y, which is dy by dx, plus y square into 3x square is equal to 5 into x minus 1 raised to 4 into d by dx of x minus y, that is 1 minus dy by dx. We have found out the derivative of x is 1, derivative of minus y is dy by dx. We have been asked to find at 1, 2. Now let us see what we get. 1, 2, we can substitute, instead of collecting all the dy terms, we can substitute 1 over here. So we give you 1 cube into 2y. So 2 into 2 into dy by dx plus y square, that is 2 square into 3 into 1 square, is equal to 5 into 1 minus 2 raised to 4 and 1 minus dy by dx. So this will give you 4 dy by dx. 4 into 3 plus 12. 5 into minus 1 raised to 4 is 5. 5 into 1, 5. Then 5 into 1 into, so minus 5 dy by dx. You take it to the side, you get 9 dy by dx is equal to 5 minus 12 minus 7. Therefore, dy upon dx is minus 7 upon 9. So it's going to be, so in these kind of cases where you have been asked to find dy by dx at a particular point, instead of, there were many examples when we collected all the dy by dx terms. We need to get familiar even with that, because if we came across many questions, you have been asked to find only dy by dx. But right now here we need to find, since the numbers are small, it's easier to substitute than collecting all the dy by dx terms together. So we have dy by dx is minus 7 by 9, which is option number A. And I suppose it could be its right answer. Okay. Okay. Now here we have y is equal to log 5 minus 4x square. Five minus 4x square upon 3 plus 5x square. Now, we need to do this. One way of doing it is using the quotient rule, but that's a little complicated. Since it's a logarithmic function, we can write it this way. We know that log of a by b is nothing but log a minus log b. So this can be written as log 5 minus 4x square minus log 3 plus 5x square. Now hence dy by dx, we use chain rule, composite function, log of any function is nothing but the inverse of that function into d by dx of the same function, which will turn out to be minus 4 into 2 into x raised to 1 minus 8x. Then here this again would be minus 1 upon 3 plus 5x square into derivative of this, derivative of 3 is 0, derivative of 5x square, 5 into 2x, that is 10x. This turns out to be minus 8x upon 4x square minus 5 minus 10x upon 3 plus 5x square. So among these options, which is this one that is right, hence we get it as minus 10x, I'm sorry, it should be 10x. So it's minus 8x upon 4x square minus 5 minus 10x upon 3 plus 5x square. And yes, we do have it that way. Okay, so what do we have here? It is this. So it's going to be f of x is e raised to ax square plus bx plus c. So f dash x, if you remember, yes, you have to remember, there's no if out here. So it's going to be e raised to a variable, hence it still remains the same function ax square plus bx plus c into derivative of this, which is 2ax plus derivative of bx is b, derivative of c is 0. So it's e raised to ax square plus bx plus c into 2ax plus b. So among these, yes, this is our option. Hence, we get it that way. I'm sure this should be the answer. Yes, quite true. Okay, now we have the derivative of the function root of y is equal to root of x plus root x. So, dy by dx, first we start taking this as u. So, it's u raised to half. So, it's going to be 1 upon 2 root u. So, it's going to be 1 upon root u. So, it's going to be 2 root x plus root x, and then derivative of this, which is going to be d by dx of x is 1, d by dx of root x is 1 upon 2 root x. So it's going to be this way. So it's going to be 1 upon 2 into x plus root 2x, 1 plus 1 by 2 root x. So among these, it is this one which is the option. So we have this as the option number C. Okay, yes, we do have that. Okay, given e raised to minus xy minus 4xy is 0, dy by dx can be proved to be what? Alright, let us see what we have dy by dx in such a case. Let's see. So, we have e raised to minus xy is minus 4xy is 0. So, let's take the derivative of this. So, it will be e raised to minus xy into d by dx of minus xy, right? Then minus 4 into x into dy by dx plus y into d by dx of x is equal to 0. So this turns out to be e raised to minus xy into d by dx of minus xy, which will be, we have to take, it's going to be minus x into dy by dx, then plus y into derivative of minus x, that is minus 1, minus 4x into dy by dx, minus 4y into dy by dx, 4y into dy by dx of it, this is 1 is equal to 0. So now we collect all the dy by dx terms. It's going to be dy by dx. There will be one term over here, minus x into e raised to minus xy minus 4x. So this term and this term are taken together. The next is going to be minus y into e raised to minus xy. If you open this bracket into this, minus 4y is 0. So eventually you get dy by dx, take it out, into minus x into e raised to minus xy plus 4. You take these things outside, you get y into e raised to minus xy plus 4. So eventually dy by dx is going to be y into e raised to minus xy plus 4 upon minus x into e raised to minus xy plus 4. This of course gets cancelled. Ultimately you're getting minus y upon x. So you have to be a little careful while collecting here. I have not opened the brackets. You can open the bracket. So basically this into this, you are taking these two. So it comes over here. When you're collecting this term and you're getting this into this is here. Minus 4y is here. So you collect all the terms which have dy by dx as a coefficient together and the other terms over there. So ultimately we get minus y by x, that is this. Okay, yes, we do have that. Okay. If x square by a square minus y square by a square is 1, dy by dx can be expressed as what? So let's see. So we get this, if you simplify it, it turns out to be x square minus a square is equal to y square. Y square is nothing but x square minus x. So in other words, y is equal to square root of x square minus a square. So that in that case dy by dx, if you remember, take this as u, This is root u raised to half, which is 1 upon 2 root u. So 2 root x squared minus a squared. Then into derivative of this, derivative of x squared is 2x, derivative of minus a squared is 0. So 2 and 2 get cancelled. Ultimately it's x upon root x squared minus a squared. Do we have it here? Yes, this we do have this here. X upon root x squared minus a squared. I'm sure you should be right. Okay. Here we have a concept, slope of the tangent to the curve y is equal to root 4 minus x squared. So the function is y is equal to root of 4 minus x squared. I told you that slope of the tangent is nothing but dy by dx. Is the same as dy by dx. So we need to find out dy by dx of this. But before that, we have to find out the slope of the tangent to the curve at the point where the ordinate and abscissa are equal. That means y and x are equal. That particular point, what is the tangent? The curve could be anything like this. So we are talking about a specific point where the abscissa and ordinate are equal. That means y is equal to x. So we need to find out that value of y and x for which it is true. So what can you do? Since y is equal to x, we can write x is equal to root of 4 minus x squared. Squaring both sides, you get x squared is equal to 4 minus x squared. So 2x squared is equal to 4. So x squared is 4 by 2, 2. So x is equal to 2, root 2. It will be actually plus or minus root 2, but when we do it, we come to know it seriously does not matter because both of them are going to be accordingly the same. So plus or minus root 2. Now we need to find the derivative of this. So at this particular point, that is x is plus or minus root 2 and y is also plus or minus root 2. At these points, what is the slope of the tangent is what we need to find. The slope of the tangent we know is nothing but dy by dx. So the first set of information is meant to find out the coordinates of the point where we have to find the slope of the tangent. Obviously, at each point the tangent is going to be different. So at this particular point where x and y both are root 2 or x and y both are minus root 2, what is the slope? So we need to find dy by dx. Now dy by dx is nothing but d by dx of 4 minus x squared the whole raised to half. So in this we are going to write nx raised to n minus 1 half into 4 minus x square raised to half minus 1, which is minus half. But we also need to find the derivative of this, and d by dx of 4 minus x square. We need to do this because there is a function within a function. In the previous example, we did it was just root of x plus 1. So even over there, we did find the derivative of x plus 1, but that turned out to be 1. Now this hence becomes 1 upon 2 4 minus x squared into d by dx of 4 is 0, d by dx of minus x squared using minus nx raised to n minus 1 is minus 2x raised to 2 minus 1. So eventually this gets cancelled. So slope is nothing but dy by dx. Let's write it clearly. Is equal to minus 1 upon 4 minus x squared. Right? 4 minus x squared. Now you want to find out the one second, let me just check out. Is it 2x minus 2x minus 2x? So it is x minus x upon root 4 minus x squared. So now we want to find the slope at this particular point, plus or minus root 2 or whatever it is. So in that case, this is going to be minus of plus or minus root 2 upon 4 minus plus or minus root 2 square is going to be minus 2 itself. This, if you take the square root, will become minus plus or minus root 2 4 minus 2 is 2. When you take the square root, you get plus or minus root 2. In these kind of questions, you can just take it as plus root 2. So these two get cancelled. So ultimately, the slope is minus 1. So slope of the tangent to the curve y is equal to 4 minus x square at the point where the ordinate and axis are equal is going to be minus 1. So once again, I just repeat, in these kind of things, we are doing two things. First is finding out the point, the required point, the coordinates of the required point where we need to find the slope of the tangent. So it's basically a curve, and in this curve there are so many points. So at each point the slope is different. So we want to find the slope, which is the derivative of this function, at a specific point. So let us first find the specific point by substituting x as equal to y, or we could even substitute y instead of x, y. Either ways, in that case, you would have got x is equal to plus or minus root 2 or y is equal to plus or minus root 2. So it's better to find the value of x because y depends on x. Now, after you know this, now you know we want to find the slope of the tangent at this particular point. So then we find dy by dx, which is turning out to be using nx raised to n minus 1 minus x upon 4 minus x square. Now we need to substitute these value over here and we end up getting the slope as minus 1. So the slope of such a tangent is minus 1. So let's see what we have here. Yes, it is minus 1. So that was an interesting problem here. Furthermore, we have a logarithmic function. So you have log of x by y is equal to x plus y. Okay. So in that case, what should we be doing? Okay. So you have log x by y is equal to x plus y. Right. So in this case, what do? We need to find d by dx on both sides. So we find d by dx of log x by y is equal to d by dx of this whole function, which is a d by dx of x plus d by dx of y. Now here, this is going to be log of x by y. The first part that is there is 1 upon x by y. Then you have to find d by dx of x by y. And this side, it is d by dx of x. D by dx of x is actually, this is x raised to 1. So it's going to be 1x into x raised to 1 minus 1. That is 1x raised to 0, which is nothing but 1. And d by dx of y, that means it is simply telling what is the change in y with respect to x, which is nothing but dy by dx. So this is something candidates remember, whenever you need to do d by dx of y, it is nothing but dy by dx. Now here, this will now become y by x. Now how do you find this? Here I'll just introduce what is called as a quotient rule. That is, when you have one function divided by another function, or one variable divided by another variable, whatever is in the denominator is squared. Then we write the denominator as it is, and it is d by dx of x. So denominator function into derivative of the numerator minus, you do the reverse, numerator into derivative of the denominator. This is what we will use this again later on. 1 plus dy by dx. So now if you see this y and this gets cancelled, so eventually y into d by dx of x is y into 1 y minus x into d by dx of y, as we did over here, same kind of thing, we write it as dy by dx upon xy is equal to 1 plus dy by dx. Now if you cross multiply this, we can get okay, y minus x dy by dx is equal to xy plus xy dy by dx. Now we want to find dy by dx. Now in that case, this again is a kind of an implicit function. We collect all the dy by dx terms together. So you end up getting y minus xy. That is, this one and this one are taken together is equal to dy by dx. You take common, it is xy, and when you take this one to this side, it becomes plus x. So plus x. Now hence dy by dx is nothing but, you can take y common, y into 1 minus x upon xy plus x, that is x into 1 plus y. So our dy by dx is nothing but y into 1 minus x upon x into 1 plus y, that is option number A. So hence we are using a rule which for the time being maybe you may find it a little, but just get familiarize yourself with this particular rule, and hence we can go ahead and do it that way. So let's check what the option is. Oh yes, we do have it that way.